Hey everyone, this is Arthur Morris. I hope all is well. In this video, we are going to look at simplifying a sum or difference of radical expressions, univariate. All right, so to simplify this, we're just going to use the techniques that we've used before. And then if we have like radicals and we have terms or factors outside of the radicals that are also alike, then we're going to combine those and keep that radical at like radical. So let's look at this and see what we have. The first one, in the first we have 19w to the 8th times the square root of w. That cannot be simplified any, but we have minus 3 times w to the 17th, which can be simplified some. We just have to rewrite that w to the 17th so it can be divided by the root of 2. So if I take this down one digit to w to the 16th, then I can rewrite that as w to the 16th times w to the first, which is still w to the 17th. But what that allows me to do is to take the square root of w to the 16th. And remember, to do that, we just divide by whatever the root is, and in this case it's understood to be 2. So that becomes w to the 8th, leaving that w to the first underneath the radical. Now, you see we have like terms or the exact same terms on the outside, and then we have the exact same radical. So I can combine these by using the same technique as before. So 19w to the 8th minus 3w to the 8th, all times the square root of w. And to do that, we just say 19 minus 3 and keep that w to the 8th. So 19 times 3 is 16 w to the 8th times the square root of w. And you know, it may have been a little bit easier or clearer to see that if we would have done it like this. If we would have said 19 minus 3 and then factoring out the w to the 8th times the square root of w, and then you can clearly see, since they both had this like factor here, w to the 8th times the square root of w, yeah, so I think that looks better. And then you still get the 16 times the w to the 8th times the square root of w. Okay, so let's try another one. All right, so in this one, we have 2y times 32y to the third minus the square root of 2y times the square root of 32y to the third minus the square root of 18y to the fifth. So let's start off with this first one here. And we have to make sure that the variables, these exponents, are divisible by 2. So we'll have to rewrite those as well. So 2y, the largest perfect square that'll go into 32 is 16. I need to write y to the third in terms of y to the second. So y to the second times y to the first. And let's clean that up. Should be 16 times 2. Sorry about that. Y to the second, y to the first. All right. 18, largest perfect square that'll go into 18 is 9. So 9 times 2. Then break the y to the fifth down. Y to the fourth, y to the first. Okay. All right, so let's see what we can take the square root of now. 16 y squared, then 9 y to the fourth. All right, so we have a 2y out here. So a 2y, let's put that in parentheses. And then the square root of 16 is 4. The square root of y squared is y, with 2y left over in the underneath the radical. Right here, the square root of 9 is 3. The square root of y to the fourth is y squared. Again, with 2y left underneath the radical. All right, so now back to the first radical, we have 2y times 4y, which is 8y to the second. Okay, so now we can see that the variable outside the radical and the radical itself, that's exactly the same. So the part that I'm looking at, this I'm saying is exactly the same as this part right here, which allows us to say just subtract 3 from the 8 and keep that y squared times the square root of 2y. So that simply becomes 5. 8 minus 3 is 5 times y squared times the square root of 2y. Alrighty, let's look at one more of these. Okay, so this one we have 19 times z to the 15th minus 12 times z to the 7th, or 19 times the square root of z to the 15th minus 12 times z to the 7th times the square root of z to the first. Okay, so let's start off by simplifying underneath the radical first in this first radical. So we have this z to the 15th, the square root of that. So we need to break that down so it will be divisible by 2. So z to the 14th times z to the first. All right, the second radical could not be simplified. So now I'm going to simplify the z to the 14th by taking the square root of that. 14 divided by 2, which is the root, is 7. Okay, so now I need to see if I can simplify this even more. If the variable and the root, the radical, is exactly the same in each one of these terms, then I can. And if we look here, we see that the z to the 7 times the square root of z is the exact same in each one of those terms. So now I can just say 19 minus 12 is 7 times z to the 7th times the square root of z. Alrighty, good people, I hope you found that to be helpful. Thank you.